Hello students, please welcome to Physics 1401 class. I believe you received my email messages I sent out yesterday and day before yesterday, and also I posted several notifications in Blackboard, and if you still haven't uh, received any of those messages, please email me as soon as possible. And next slide, I will show you my email address. The course website and my contact information. My email address is wpriyantha w.priyantha at tcc.edu, and here's the university website. And I also post a link to Blackboard lessons, and you can copy and paste this link, or you can log into Blackboard and access your notes and lab assignments. And my name is W. Priyantha, and I go by my last name, Dr. W. Priyantha. Um, so let's talk about the textbook. I use Cutnell and Johnson 11th edition, but I know some of you already have a older version, like a 10th version, 10th edition. When you work on problems, make sure the some of the questions on 10th edition question numbers may not match with the question numbers on 11th edition. So make sure when I assign problems, you double check the right problems with the newest version. And I have both versions, and I will also check whether these problems are exactly the same on 11th and 10th editions. So let's go to chapter 1, Introduction to Mathematical Concepts. In this section, I briefly talk about working with large numbers, trigonometric relationships like Pythagorean theorem, sine cosine relationships, and then we can talk about units, and we can discuss how we convert one set of units to another set of units. Before we go to mathematical concepts, units, I want to ask you what is the meaning of physics? Uh, Physics is study of materials, or study of universe. So the entire universe made out of small particles to huge astronomical objects. So, so physics is a study of materials. So our first topic is units. Every physics experiments involve in measurement of various quantities. For example, if I give you a very hot object, you can measure the temperature using a thermometer. So there are different types of thermometers. So the final goal is, whichever the type of thermometer you use, your final measurement should be accurate. So these measurements should be accurate, and also you have to have reproducible. So there are certain several different types of units for measuring a length. You can use inches, you can use feet, you can use meters, you can use centimeters. So you can have so many different types of units to measure a certain quantity. For example, another example, like a mass, you can use several different types of units. But if you know one type of units, you can learn how to convert one unit to another type of units. If I give you a quantity with certain number of inches, and if I ask you to convert that inches to centimeters or meters, you need to learn how to convert one set of units to another set of units. Mainly there are two units systems we use in US. The first one is a US customary system based on foot, pound and second, and the second system is metric system based on meter, kilogram and second. So the scientific community use metric system or SI system. The metric system has advantages over US customer system, and therefore the metric system or SI system we use nationally and internationally as the main unit system, and we abbreviate as SI system international. SI system or SI units, there are three different units: meter, we use abbreviation M for meter, for measurement of length, and kilogram we use kg to measure a mass, and second we use lowercase s for second, and which is unit of time. Meter, kilogram, second we use for measuring length, mass and time. Conversion of units. As I mentioned earlier, there are two systems we basically use, US customer system and SI units. So for example, if I give you one set of units, and if you know these conversions, you can convert one set of units to another set of units. So these conversions are really useful when you convert in units. So 1 feet is equal to 0.3048 meters. 1 grams is equal to 0.035 ounce. 1 mile is equal to 1.609 kilometers. 1 horsepower is equal to 746 watts. 1 liter is equal to 1.056 quart. 1 liter is 10 to negative 3 cubic meters. So these conversions, when we assign a homework problem or test problems, we will provide these conversions, and therefore you can use these conversions and convert one set of units to another set of units. Okay, so now let's learn how to convert one set of units to another set of units. There are some basic steps you can follow to convert these units. You know, when you hear these steps first time, it's a little bit confusing, but once you learn a couple of examples, you will realize how easy to follow these rules for you to convert one unit to another unit. So the most important thing is we use 1, because any number you can multiply by, divide by 1 without changing the magnitude of that number. So here, if you have given a one set of units, you multiply that number by 1. I will tell you next slide why you multiply by 1. Okay, let's take an example and see if we can use the steps to convert 1 mile into inches into 1 mile. So the question is, how many inches in 1 mile? Let me select a pen. 1 mile, because how many, we don't know how many inches. inches. Okay, so 1 mile equals 5280 foot, which is our conversion, which is given. You need to know one conversion in order to calculate how many inches in 1 mile. So 1 mile equals 5280 feet, which is given. So you multiply this by 1. So what is this means? What is this 1 means? So as I mentioned you earlier, multiplying by 1 doesn't make any change to this 5280 foot. So it is still 5280. So, but what we know, uh, 1 feet has 12 inches. So we can use this to make this 1. So we know 1 foot has 12 inch. So if I divide both sides by 1 foot, 1 foot, 1 foot divided by 1 foot, cancel, you get 1. So this side is 1, the other side is 12 inch divided by 1 foot. So this 1, instead of 1, because this side is 1, instead of this 1, we can substitute 12 inches divided by 1 foot. So the reason I did that, so if I do that, you have 5280 feet and divide by 1 foot. So you cancel foot with the foot on this conversion. So therefore you end up in inches. So your final answer is 1 mile equals 5280 multiplied by 12 inches, which is 63,360 inches. So when you make this 1, you can use the second conversion given, and you can write this conversion such a way that you can cancel 1 unit with the unit, same unit in the conversion. So you can make this 1, 1 feet is equal 12 inches. You can divide both sides by 12 inch. 12 inch. So now you can cancel 12 inch to 12 inch, and you still can make 1, but here you have 1 foot divided by 12 inch. But you cannot use this here, because here there's no way you can cancel this foot with the 5280 foot in the given conversion. So you have to rewrite this conversion such a way that one set of units cancel with the same units in the conversion. So that's why you have feet here, and you can cancel with these two and leave left with inches, which is the answer to your question. Okay, here's another example. The highest waterfall in the world uh, has a 979-meter drop. You have to convert this drop in feet, basically meters to feet, and you have given a conversion factor and meters to feet. So 979 meters multiplied by 1. So how you make this 1 using this conversion? Make sure you have meters here. So when you make the 1, you have to have meters here so that you can cancel these meters with the meters in the conversion. So 1 meter and 3,281 feet. This is your 1. This is your 1. So 3,000 3.281 feet equals 1 meter. And if you divide both sides by 1 meter, you have 1 in this side. So that one you substitute here, and other side of that equation is 3.281 feet divided by 1 meter. So now you can cancel meters to meters, and your final answer is 979 multiplied by 3.281 feet. And this is your final answer. Okay, let's do another example. This is a little bit hard. Actually, this is the hardest type of conversion problems you will see. In this problem, you have to convert 65 miles per hour, 65 miles per hour into meters per second. So basically, you have to do two conversions, miles to meters. Miles is the units of length. You have to convert to units of SI units of length, which is meters, and hours, units of time, and you have to convert to SI units of time, which is seconds. So basically hours to seconds and miles to meters. There are two conversions. That's why you have 65 miles per hour multiplied by two ones. One of these ones represents for one conversion, which is miles to meters, and the second one represents the conversion of hours to seconds. So let's start with 65 miles per hour. Okay, so multiplied by, so now first let's try to cancel miles using given conversion. So the first conversion is 5,280 feet is equal to 1 mile. So I'm going to write this equation, which is 1, in such a way that you can cancel these miles with the miles in the given conversion. So I have to cancel these miles, so that I am going to write mile here, 1 mile, and 5,280 feet. Now we have another problem. Now we can cancel mile to mile, but now you left with feet. So how you going to convert feet to meters? Now you have a second conversion. So now you can cancel this feet with the feet given in the conversion, which is 3.281 feet. 3.281 feet multiplied by 1 meter. So now we convert miles to meters, but we halfway through, so now we have to convert hours to seconds. Let me use a different color to work on the second half of this problem. So 3,600 seconds is equal to 1 hour. So you have hours here. So in order to cancel hours, you have to multiply by 1 hour divided by 3,600 seconds. So hours cancel, and now you have miles cancel, feet cancel. Your final answer is meters per second. So now you can rewrite 65. There are no units here because all cancelled. 5,280, and the third term is 1 divided by 3.281, and your final unit is meters. You can use m for meters and seconds. So this is your final answer. If you do the calculation, I think the final answer is 29 meters per second. This small section helps you to understand writing numbers as exponents, which helps you to understand the next few slides. So negative exponents like 10 to negative 1 indicate a small number. So if you have like 0.0005, you can write, you can shift this decimal point 1, 2, 3, 4 positions, and you can write 5 times 10 to negative 1, 2, 3, 4. 5 times negative 4. Let me take another example. 5. You can write this 1, 2, 3, 4, 5 positions. 2.5 times 10 to negative 5. And similarly, large numbers you can write 100,000, 10,000. So decimal point is here 1, 2, 3, 4 positions to left, and I can write 1,000, 10 to 4, 100. So decimal position is here 1, 2, 1 times 10 to the power 2. The reason I write these small numbers and large numbers as of with the exponent is there's a reason for writing that, and I will show you in a second. Okay, let me take an example and show you uh, how you can understand these prefixes in problems, and how you can use these prefixes. Let me take an example. Let's say 0.00. Decimal point is here, 3 grams. So you can write this. You can shift the decimal point 1, 2, 3 places to right, and you can write 3 times 10 to negative 3 grams. Okay, so from this table we know 10 to negative 3 is milli. Okay, so therefore instead of negative 3, 10 to the power negative 3, you can write milli. Milli means m for milligrams. So 0.003 grams equals 3 milligrams. Or you can take, let me take another example, 0.004 seconds. You can write 4 times 10 to negative 3, 1, 2, 3 seconds. Okay, so 10 to negative 3 is milli, so you can write 4 milliseconds. Okay, let me take another example, 1000 grams. You can write 10 times 1 time 10 to the power 3 exponent grams. So 10 to the power 3 is kilo. Therefore, kilo is K. So you can write 1, 10 to the power 3 is kilograms. So you can use prefixes, and also you can write the numbers in terms of exponents and use these prefixes, and you can write large numbers or small numbers with certain units in the same units, but with this help of these prefixes you can make it short. Okay, let's do a couple of examples to see you understand the material we covered so far. The first example is meal plan hai, use a quarter pound of meat per serving, and there are 12 people will be at a meal. So we can check how many pounds of meat we need to serve 12 people. So we need 4, 3, so 3 pounds of meat. And now we have to calculate how many kilos of meat we need. So which means we have to convert pounds to kilos. So we have to have conversion. So 1 pound is equal to 16 ounce. So from this we can convert these pounds to ounce. So now you can multiply by 1. You can make 1 out of this equation such a way that to cancel this pound with the pounds in the conversion. So which is divide by 1 pound and multiply by 16 ounce. So pounds cancel with pounds, but now you have ounce, so you have to have another conversion for ounce to kilo. So the second conversion is 1 gram is equal to 0.35 ounce. So you can write this one 0.35 ounce 1 gram. So ounce cancels. Now you have 3 times 16 times 1 over 0.35 grams. So now we have to convert grams to kilograms. So once you get the answer, you can convert grams to kilograms, so basically you just need this in powers of 10, and we know 10 to the power 3 is kilo. So you can write this number as powers of 3, and then instead of 10 to the power 3 you can write kilograms. So that's what you need to do to complete this problem. Okay, let's take another example. Okay, here there are several examples. You have to tell any of these scenarios, A, B, C, D, E, are likely or unlikely. For example, the first one is 20 centimeter tall. One student is 20 centimeter tall than the other student. So, when you talk about centimeters, if you are not familiar with centimeters, it's easy to convert centimeters to a familiar unit like inches. So, let's convert 20 centimeters to inches and see, is this a likely scenario? So how you convert centimeters to inches? You have to have the conversion. So 1 foot is equal to 30.48 centimeters. So 30.48 centimeters, 1 foot. So 20 divided by 30.48 is, let me do the math, 20 divided by 30.48 equal to 0.65 foot, and you can convert foot to inches, can multiply by 12, which is 7 inches. So it looks like it's a possible, because if one student is 5 feet tall and the next student is 5.7 inches tall, so it's a possible scenario. So it's a likely case. Let's go to B. This is A. Let's go to B. Dog's tail is 300 millimeters long. Again, if you are not familiar with millimeters, or if you are not familiar, it's easy thing to do is to convert millimeters to a known quantity like inches. So in order to do that, you have to have the conversion. So let me write the conversion. 1 inch as 25.4 millimeters. So you can convert millimeters to inches using that conversion. So you have to cancel millimeters with 25.4 millimeters and 1 inch. So which is equal to 300 divided by 25. 300 divided by 25, which is 12 inches. So dog's tail, 12 inches is 1 foot. It's possible. It's a likely scenario. And part C is height of a ceiling is 2 meters. 2 meters. So if you are not familiar with meters, you can convert to foot. So 1 meter is equal to 3.28. So now you can convert this to foot. 1 meter, 3.28. So meters cancel. So 2 times 3.28 is equal to 6.56 feet. So it's possible, 6 feet tall ceiling. Yes, it's possible. Okay, so similarly, if you are not familiar with one set of units, the part D is kilometers per hour. You can convert to miles per hour, which is more convenient or familiar unit for us. So, and you can say, okay, is a likely scenario or unlikely scenario, just looking at the new units. And you can do the other problem, second one as well. Okay, so the next topic, subtopic is role of units in problem solving. And following equation is this equation x equals v times t is dimensionally correct. What this means, if you have a equation, whatever the units in the left side needs to match with the units in the right side. So it's like a scale, so because it's equal, so the units, magnitude and units. So if you have 10 kilograms, you have to have a certain amount of certain number here, and it match with a similar units of mass. So it can be pounds. If I give you another example, 100 miles. If you do a conversion, you can have a magnitude and then you can convert to inches. So this is a unit of length. This is another unit of length. So you have to have the right units, so you can start with miles and you cannot end up with kilograms because those units are not matched. So you have to have right similar units. It can be metric, it can be US customary system or CGS, but it has to have right dimensions. So let's see this equation is dimensionally correct. X is a displacement, which is a distance. So the dimension of distance is L, and then which is equal to dimensions of velocity, which is displacement over time, unit of distance or displacement, and dimensions of time, which is uppercase T, multiplied by T. So you can cancel T to T and you have L is L. So your dimensions of the left side is equal to dimensions of the right side. So length we use L, mass we use uppercase N, time we use uppercase T. Here's another example. X is displacement, which is equal to half velocity time square. So distance or length we use dimension L, velocity we use dimensions of length over time, L over T, and time square, T square. So 1T cancels with this, and LT. So which means right side is L, left side is LT. So these are not equal. So this equation is dimensionally not correct. So which means this is not an accurate equation. Okay, so in this section we're going to learn or memorize a couple of trigonometric relationships we learned. And so these relationships associated with right hand triangle and three sides of this triangle and also the angle. So if you consider this is the angle we are interested, so this angle theta and this is the 90-degree angle. So the side opposite to this 90-degree we call it hypotenuse. The side adjacent to this angle theta we call it adjacent to angle theta. Sometimes this side length is we use HA is adjacent, and the side opposite to this angle length of side opposite to angle theta, O means opposite, so HO, so length opposite to this angle. So if you use this one, let me use a different color. Let's say this is beta, so this side is H opposite to this angle, opposite the side opposite to angle beta. Angle beta. So depending on the selection of your angle, opposite angle can change. So side can change. So if you use this, this is your opposite. If you use this, this is your opposite length. Okay. Okay, so here's the same triangle we used in the previous slide. And if you consider this is your angle of interest, angle theta, sine of angle theta means opposite side, which is opposite to this angle, length of opposite side h naught divided by length of hypotenuse h. And if you use cosine theta, this is the angle again, adjacent side of this angle theta, which is this HA divided by h is hypotenuse. Okay, tan of theta means, again, this is the angle theta, opposite side, length of opposite side divided by length of adjacent side, which is the adjacent side of this angle. So if I give you an example, let me give you an example. Let me draw a different triangle. Okay, let's say this is your 90-degree, and let's say your this angle is 20, and let's say this side is 5. And my question is, what is the length of h? So you have one angle which is given, we know this. So this is opposite, which is 5. Opposite to this angle is 5, and the question is what is the length of hypotenuse. So opposite and hypotenuse. So then you know you can use this, because this relationship, sine of this angle, sine of 20, which is equal to opposite side, length of the opposite side, which is 5, divided by h. H is equal to 5 over sine of 20. Okay, that's one. Okay, let me give you another example. This is the 90 degree, and let's say this is 30 degrees, and this is let's say this is 6, and what is the length of this? So because from this figure you can see this is the side of this angle. If you talk about adjacent side, length of the adjacent side, which is, you can use this relationship, because angle of cosine angle is equal to length of adjacent side divided by hypotenuse. So cosine 30 is equal to length of the adjacent to this angle 30, which is HA, we don't know, and hypotenuse is 6. So HA, length of the adjacent side is equal to 6 times cosine 30.